So today, as Nathan said, I'll be looking at classroom robotics across different learning areas. And Nathan did a lovely job of introducing me there. The other thing that I'll add to that is uh, my role at the Brainary is to work with schools across Australia and also with NDIS clients around assistive technology. So have a bit of experience working with within special education alongside STEM education, and really enjoy using digital technologies for a purpose. And there's nothing better when seeing them implemented successfully and making a meaningful impact on someone's classroom or on someone's life in the case of assistive technology. So I'll just touch on a little bit around who the Brainary is, and then I'll get into what I've got planned for today and get into the meat of it. So the Brainary, we're a STEM education assistive technology company in Geelong, and we work across schools, universities, and work with NDIS clients and public libraries around implementing digital technologies. One of our main areas is robotics, and we've had some really interesting case studies and successes of using robots across K-12 and also in I guess more healthcare applications, with some really fascinating things happening in some of the hospitals around rehabilitation with humanoid robots. But I'll leave that to the side for the moment and jump into what I've got planned for today's session. So the main meat of the session will be from now until about 20 to 5, and then we'll have a bit of a Q&A after that. So the first thing I want to do is frame up a bit around STEM Ed and STEM and why that's important from the perspective of using robots within the classroom. One thing that I like to use and help with how I frame up robotic units and activities is two useful frameworks, TPACK and SAMR. You may be familiar with them, you may not. I think they're helpful from my personal perspective of when I try and develop different units. Then I'll talk a little bit around why I think robots are a really good tool to use in classrooms. Look at planning and implementation, and then I've got 3 examples that we can have a look at. And as long as I've timed everything correctly, I'll change my webcam, and I've got a little bit of a setup with a couple of robots there to have a look at with those examples. As Nathan signposted earlier, a lot of my sort of theory and how I like to implement robotics is based around STEM education, and that's why I'd like to start there. So I think the key thing around STEM education from my perspective, and also with robotics in mind, is that STEM education is a great way to really put the real world context into what we're doing within classrooms. And I think we can get caught up on definitions around STEM Ed and STEM education, but I think at the end of the day it comes down to what we're doing in the workforce in the real world when we're sort of engaging in science, technology, engineering, and maths, is that they're all coming together in multidisciplinary, cross-disciplinary ways. We don't really use one in isolation. There's always an important context around that, and when we're able to take that context from everyday life, whether that's what we do on a day-to-day basis outside of school, in industry, in other workplaces, in the community, and bring that into the classroom, then I think we can get really good engagement and really enrich learning. From my perspective, robots give us a great vehicle to do that. But I think coming back to STEM education, really just around getting that cross-disciplinary implementation. And I think it's important to keep in mind that you don't have to be doing the S, the T, the E, and the M, and potentially arts, the A in there all at once. You can do parts of it together and separate, and depending on what is the easiest and most relevant way for you to do it in your context. Don't be afraid to customize it to what you're doing. So as I was saying there, I think the purpose from my eyes around STEM education is really around building that context. And I think with that in mind, some of the literature around that is talking about some of the sort of looking at it from a 21st century skill perspective. So I think they're starting to push the I guess the difficulty around putting a definition on STEM and STEM education aside, and look at the skills that we can sort of cultivate by teaching in this way. And I think whilst I won't touch on it today, project-based learning and design thinking are wonderful ways to look at that as well. But some of the key skills that I think we can develop with these sort of projects is the 4 C's, which I've got written down there, which I think are critical to any sort of future for our students, and really critical for the classroom as well. As I was discussing before, I think TPACK, when I was studying STEM education at Monash, was something that really resonated with me, and that's why I'd like to share it. But at the same time, if it doesn't resonate with you, I won't be offended, and you use what is relevant and what is useful to you. But I found the idea that when we're looking at how we use technology in our classrooms, whether it's robotics or virtual reality or anything else really, is looking at what sort of knowledge we need to cultivate ourselves to be able to successfully do it. I think a lot of the time, some technology can be seen as something that is disruptive and not, it's going to change what we do and really make it more difficult to actually deliver the outcomes we want to deliver. And when things go wrong, it's easy for us to abandon them and move on to what we know works consistently. But I think using this model here, I found it helpful to look at it from the perspective of, okay, what sort of content knowledge do I need to have around the technology that I'm going to use? And then how should what's the best practice of delivering that knowledge to my students, combining that with what I already have from a professional practice perspective around pedagogical knowledge and content knowledge, and bringing that all together. So I think, if you identify an area that personally you think you might be worthwhile working on, whether that's some content knowledge around technology, some pedagogical knowledge around technology, it helps frame up how that might come together to get a better outcome. The other framework that I found really useful as well was the SAMR model. Some of us, I'm guessing this has been sort of taught for a fair bit to educators, but I think this really helps from a whole school perspective to look at different ways to slowly embed technology into our classrooms and do it in a step-by-step manner that allows us to build complexity around that technology as we build capacity to do so. And I think it is really helpful from the context of building capacity and taking it one step at a time. It's okay for us to start small and build up. We don't have to be redefining everything we're doing with technology straight out of the gate. We can take our time and start to pivot our teaching practice using a model like this. And I think it's definitely helped me with how I deliver professional learning and look at implementing robotics and technology within classrooms. So onto robotics, which is really what I want to focus on today, is the why. Why robots? Why are they helpful? Why are they useful? And why should we care? Robots, as demonstrated by a whole host of educators, but one who's definitely pioneered this sort of movement was Seymour Papert. I think the key thing was that we get hands-on, we get practical, we can actually see the manifestation of complex ideas and thinking right in front of us, and we can interact with it. And I think that hands-on element, whilst it's been difficult during the last 18 months with COVID-safe limitations, is really helpful and really important to change the way that students are engaging with these concepts, and another way to give them another option for them to understand whether it's complex ideas around mathematics, science, technology, and maths. I actually tapped forward a little bit there, but that's okay. Moving on to the planning side of things, which I'd like to focus on a bit more. When I start to look at planning a robotics unit within a classroom, I like to do a bit of a stock take to see what sort of resources we have and what sort of resources we need to add. So with that in mind, I like to open the cupboards. I'm doing this with a school at the moment in Geelong, and there's a bit of a robots audit that we're doing, and we've found, I think, probably a list of about 10 different robots sitting in cupboards, some new, some used, but there's a huge amount of resources there that we can build off, and we don't necessarily need to look at adding from a technology perspective. We can look at what's already there. But I think it's looking at what is around us within our school, but also within our school community that we can leverage. Another aspect that I think is really important around that planning is what are our key themes and topics for the year? And this comes down to one of those 21st century skills that I talked about before, which is communication. And that is really important when we're looking at how we can take robotics out of just the digitech space and maybe a very specific STEM subject and across into, or a very specific technology subject across other areas, sort of mainstream curriculum areas. Within the primary context, my understanding is, and my experience is that we're seeing a digitech specialist or STEM specialist being deployed across primary schools, and their sort of contact time with students of the different classes and different grade levels is roughly about 1 hour a week. Naturally, this will vary across different primary schools, but the key thing is if you're seeing a group of students 1 hour a week, how can you develop and implement a really engaging and worthwhile Digitech STEM Ed project with that amount of time? And one of the ways that you can actually do that is starting to get access and communicating with your fellow teachers and your colleagues around what topics they're delivering across the term, and looking at ways that you can apply what you're doing in that 1 hour to those topics that are coming through each term, each year, each week. So I think that's one of the really important areas to start, is just having that communication, that dialogue between teachers in those different grade levels in that primary context. And then the same thing becomes relevant when we move up into that secondary context, where if we're looking to do that sort of cross-curricular activities and within the classroom, we need to have really good lines of communication between our different departments, so that we can actually look at ways of making, rather than adding more to our workload, we're optimizing and getting cross-curricular outcomes so that we don't have to sort of double up on what we're teaching, but we're able to get some really engaging projects with robots or other digital technology. Alongside that, I would also suggest, and I've found this quite useful, is looking at what's actually going on campus and around us that are important issues that we can focus on, that we may be able to look at through the lens of a design thinking, problem solving, project learning style of STEM or robotics project. A really good example of this is a school I'm working with in Geelong. They have a plover problem, or a plover nesting consistently at their school every year, and each year when they nest at the school, they need to get wildlife services to come in and remove them from the school. It has some issues around child safety and scaring some of the students. And what we were looking at is, we've got an issue that's solved by Parks Vic coming in to relocate the birds. But what can we do around this problem to make it a better experience for students, a better experience for the plovers, and how can we use this sort of problem that we have at school, this issue, and look at building a project around this, and that builds in a lot of different curriculum areas, because we can start looking at what's going on within the environment, what's going on within our school, why are they picking to actually nest at school in our area. So it's important to look at what's going on site, whether that's at school, and then branch out further into larger sort of areas around local, state, federal, international. And then we've got a really interesting context to engage our students in that, is actually really relevant to them and engaging to them. Next, I want to move on to our first example, and I've got a very small window for my camera, so hopefully this will come up for us when I swap cameras. What I'll do is I'll just talk through the activity, and then I'll swap cameras and give you a look at how that might actually work, and hopefully that'll come through nicely and make sense. So what I've got here is a primary aimed activity. This can be built out into a larger unit of work, or it can be a discrete activity that we do over an hour or a couple of hours, depending on what suits what we've already got planned for the term. So the idea here is that I'm using the Kubo robot to engage with some concepts around computational thinking and also geography. What I'll be doing is I've got a nice map of New Zealand. So I'm hoping that we'll all be able to travel across the ditch soon. So maybe a bit of wishful thinking from me there. But what I'm going to be doing is I'm going to be asking students to plan out, it could be a holiday, or it could be an adventure between different parts of New Zealand, different cities, different places. And what they're going to be doing is using Kubo's programming tiles. They're going to create a journey for Kubo from different places, and then using those locations as the prompt to actually do some research around that place and talk to us around why they want to go there, and what's special about that place, what's interesting about that place. So we can start to look at maps, we can start to look at locations, we can start to look at geography around mountains, rivers, all sorts of different things around that. So we can have a bit of fun and creative license with what we're engaging with there. So without further ado, what I'll be doing is changing my camera, and I'll stop sharing for a second so we get a bigger video stream coming through. That is what technology sometimes throws at us. So what I've got here is my map of New Zealand. We've got the North Island up here, part of the South Island, and then we cut off with our camera. What I've got circled in red here is Wellington, which is coming through backwards. But what I've got here, so I'm going to be going from, a start point is Wellington, and what I've mapped out here is a route to get me to New Plymouth. And because I am a keen surfer, we'll be going from New Plymouth on to Raglan and then to Auckland. Now, the first thing that we'll be working with here is we'll be working with routes. So the idea is that I'll be using Kubo to create a set of instructions. This would probably be, if we're just starting with routes, we'd probably be looking at sort of foundation to 2, and we'd be looking at just creating a small algorithm here that's easy to follow, that's getting me from point A to point B. And what I can do here is pop Kubo on top. and I should have arrived at New Plymouth from Wellington. So I can start to look at some of the places that we've gone past on the way and look at any interesting aspects of that. We can start doing some research around Plymouth, New Plymouth, and talk about what's there, what is that place, why are we even visiting there, and build a bit of a narrative around this. What we've introduced here is just routes, which is just simple instructions for our robot to follow. If we want to go and make that a little bit more complex and potentially start engaging with a higher age group, we can start then moving towards creating a function. So I'm going to change this and we're going to go to one of my favorite places in New Zealand, Raglan, which is just here. So to get there, I need to take the following route. Which Kubo has successfully done for me. The next thing I can do is look at turning this here into a function. And what I'll be doing is taking a very straightforward and easy to make sense of route. When I turn left, I can see that I'm turning left and it actually maps out and follows. I'll be moving to a linear way of representing that. So we'll be looking at representing this information differently, which you can start to see me build down the bottom. Now, at the moment, because I've already drawn out my route, it's fairly straightforward that this will work. So I'm confident that this will work. And that's all well and good. I can save this in, and will have saved my function into my robot here, and then it can start to engage in my context of the map of New Zealand. So I should be able to put Kubo here on Wellington. And all being well, I should end up at Raglan. Not bad. Now, we can make this a little bit more complex by, rather than being able to map out physically where I'm going, to do it from imagination or do it in an abstract way and sort of go, yeah, if I want to get from A to B, I'm going to have to go a certain number of forward, certain number of left, certain number of right, and how I put that together. So we can start to make it a little bit more complex. And then if we're wanting to add a little bit more complexity, we can look at adding multiple stops along the way and then build more of an interesting narrative around why we're stopping at those different places. And that will just be using a few more of our programming tag tiles to do so, and creating another function so that when our robot arrives at Hamilton or Raglan, that it hits another function and starts moving on to the next location. So we're starting to engage with some ideas around geography. We're also starting to engage with some basic computational thinking ideas and programming ideas, and we get to see it physically manifest in front of us with a arguably cute robot. What I'll do now is move back to the presentation. So bear with me while we jump back into the slides. So the next activity that, so as an example that I'd like to have a look at is a bit of a case study from a friend of the Brainary, Frank Costello from Xavier College. So Frank put together a wonderful blog post for us, which I'll share in the chat at the end, where he looked at how we can use light and rainbows in the context of robots and a science classroom. So I found this really amazing because of the way that, and a really useful way to look at integrating robotics across the curriculum. So what they've done here is they've got two classes or two sessions where they start to look at the concept of light and rainbows and the creation of rainbows. So they'll be using light boxes, triangular prisms to actually physically create their rainbows, and then bring in a robot with a light sensor to actually pick up that rainbow that's been created and to give us a data plot and an EMS data plot of that. So we can actually start to sort of bring together a complex idea into a really interesting and engaging way. So the key thing that I took away from this was that when they brought robots into a science class, it was a co-delivered session where the robotics teacher supported the robotics element of it and the science teacher supported the science element of it, and they came together to deliver the session. So there was some planning together to get that done, and a bit of work across the departments to successfully implement it. So I think that was a really good example of good communication and being open to trying something different to build more engagement with the students, and then also build capacity and confidence with the science teachers around using robotics within their classrooms, because it's a really fun and interesting way to teach those ideas. Now, I just realized that I've got the wrong window pin, so I'll just make sure that the correct one is pinned. I'm not sure if it's for everyone else. But in essence, what happened was the first lesson was focused on discussing the science behind electromagnetic spectrum, and then viewing a video as an introduction. So we get a nice bit of mixed methods to look at this concept. And then following on from that, so we got the theory behind what we're looking at and why it's relevant. And then in the practical part of this, we had the light boxes and the prisms, and then we had the robots with the light sensors, and we're able to use those together and then map out the light that the robots were picking up through their light sensor. Now, that leads me to looking at data collection and science experimentation in general. And I think this is a really rich avenue to go down with using robots across the curriculum. So no matter the robot that we've got, and there are a huge amount available in the marketplace, it will have some form of sensor. And depending on the sensor and depending on what data we can extract from that robot and the software that we have access to, there are opportunities for us to use that data collection to help us investigate and experiment with some interesting science curriculum items. So a lot of robots will be having thermometers, temperature sensors, we've got cameras and light sensors, we've got distance sensors. The image that I've got up on the screen there, I've got color sensors, distance sensors within that robot there that are useful for navigation, but I can actually use those to engage with other concepts. And a really fascinating one that we're excited to release hopefully at the end of the year is using a color sensor within a machine learning based algorithm to sort of understand the ripeness of a tomato. So you can really use these sensors in different ways and in creative ways. The final example that I wanted to go through is robot soccer. So here we've got a really tried and tested model of engaging students and using robots in different curriculum areas. My colleague Lisa and I put together an example 10-week unit of how we might deliver this for a Year 7-8 cohort using the Fable robots you can see on screen there. So the whole idea around this was to use sport as the context around our robots here, and to build different curriculum items around that. So aside from the programming aspect and the Digitech aspect there, we've added some construction elements and some reflective elements and opportunities for us to actually use the English curriculum, the science curriculum, and the maths curriculum alongside those sort of computational ideas. So what I will do next is just go through the example activity or outline here that we've got. So week 1 is where we would start off with an investigation. So using some open-ended questions, students would look up relevant words and describe how they're going to build and program their robots. Moving on from that, the following week we'd look at actually the physical activity of building our robot. So in this case, we'll be using the robot that should be popping up on my screen down the bottom there, which would be building our robot here. So putting together the different components to allow a robot to drive around and actually score some goals. From there, we'd start to look at how we're actually going to program those robots. So be introduced to the Blockly programming that we start with, getting their robot to move around with that basic code. Once they're understanding that, we'd then move on to a reflection. And the main sort of outcome or goal of that reflection is to reflect on what we've done with our code so far. You know, what can our robot do so far with the Blockly code that we've been able to use? What do we need to add to it, and how would we like to add to it? And then following on from that, based on that reflection, we go in and into a practical way, try and implement those reflections. So, you know, is there a way for us to use some of the sensors in our robot to autonomously move around? If my robot is the goalie, should I put together an algorithm where it moves back and forward on a set routine that's repeated to defend the goal, or should I have manual input, human input on that? Following on from that, we added in a sort of opportunity for English curriculum where we wanted the students to actually write their own story about a robot that wanted to be a soccer champion. So wanting them to think creatively about that and write about that. Following on from that, then we start to look at some more advanced code that they can potentially implement with their robot to improve what they've already created in order to solve that problem. And then getting a bit more hands-on and a bit of design, we're actually going to get them to design the field that they'll play robot soccer on. So looking at what requirements we have for the field and building that. And then in the last 2 weeks, we'll have our sort of dress rehearsal, which is our final opportunity to test our code, make sure everything's working, and that we're ready to go for our week 10 tournament or carnival. And that's where we play for real and see how well we've programmed our robots. I've got a little bit more information that I can share in this with another blog post that I'll pop in the chat at the end. But there are some examples of how we can start to look at robots across different curriculum areas. What I will do is stop sharing for a moment and make sure my video's pinned to give you an example of actually, sorry, I'll change which window I'm presenting to. So I'll just open up our programming software for the Fable robot that I've got there. So just double check that my robot's switched on, which is always the important thing. So my robot should be switched on and connected. So what I've got here is just a very simple bit of code to allow me to control my robot using my keyboard. So if I hit play there, I can start to drive my robot around with some fairly basic commands, and I've got my little ping pong ball here, which acts as my soccer ball. So this is an example of some of that basic Blockly code that we can start to use with students to get their robots to start mimicking or trying to be a robot soccer player. And then we can move on into creating some automated sort of algorithms that won't require us to actually put any input in the sense of real-time responding to where the ball is, and we can just hit play at the start of the game and see how they go and see whether we're actually able to score any goals. So we're very close to 440, so I'll just quickly sneak in one last example if I can. My cursor just seems to have disappeared from my screen. So what I've got here on the screen is a little bit of example code where I'm starting to use my light sensor, which is on the front of our robot there. And I've got a little laser that I can shine into my robot. That will get my robot to start to move based on the amount of light that it's getting out of its light sensors. So hopefully that's coming through on the cam there, but essentially what's happening here with our light is that I've got sensor 1 and sensor 3, and then I've matched them up to left and right so that if I get light coming through sensor 1, then that will correspond to my right wheel, which is B, and then that'll activate that. And likewise, I've got that set up for A for the left, and I've just said on the left that we'll go negative for A, so that it will mean that because we've got two rotational servos here, that they'll go the correct direction to allow our robot to move forward or left and right, depending on which sensor is being triggered. You notice that if I shine the light directly in the middle, it should pick that up and go forward, depending on the light that I'm shining into my sensor there. Now, I think we're just going over to 442, so I will relinquish the share, and the final things that I wanted to share with you actually, was just some final tips and thoughts that I find really helpful myself once that screen pops up. So I think the most important thing that I've found with sort of trying to implement cross-curricular robotics activities is are these tips around communication. I think we really need to have good communication between all of our team members that are going to be involved or need to have some input in this process and this project. I think starting small and building is the right way to go. It's important to understand the sort of resources and commitment that we need to successfully do this. And it can take time. So be open to, allocating a longer sort of roadmap to have this actively happening within your school. And that's okay. You can build capacity. And at the end of the day, people are the most important part of this. I've seen programs at schools that are really successful, and they're driven by one or two key people. It doesn't matter whether we're in a school or a corporate or any business. If we lose key people, we can, projects fail and we can have a really hard time, getting the outcomes we want. So I'd say people are the priority, and working together to get that happening is the key thing. So I've run a bit over and I apologize, but thank you, and I'll open it up to questions.